Hello, we are Five Star Design Group, and this is our senior design presentation. My name is Bryce Jones. I'm the transportation lead.
My name is Joe McMullen. I'm the geotechnical lead.
My name is Peter Babelta. I am the hydrology lead.
My name is Wangchen. I'm a structural lead.
My name is Clint Martin. I'm the visualization lead. Now to move on to kind of a project overview.
The building that we've designed is located in Nampa, Idaho. Its use will be industrial manufacturing. It's going to have raw materials brought in by a variety of different trucks, ranging from vans to pickup trucks and medium-duty trucks. The finished product will be loaded via a hopper into SU-8 trucks with a gross vehicle weight of 80,000 pounds. The building footprint is 6,509 square feet, and the building has an intermediate floor or mezzanine. The structural materials is structural steel, and the finishes include masonry facade, but the masonry was not factored into the structural component. The site also contains a stormwater retention facility, as the owners requested that all stormwater be dealt with on site. None of it leaves the site. A little bit of information on the site itself is that there's a river to the west with a base flood elevation of 2,507 feet. And as you can see in the next slide, this is the existing layout that we had. Running across approximately the middle of the site is our base flood elevation. Entrances will be on the east side, with parking on the west side and a stormwater retention facility on the southwest side of the site. Moving on to geotechnical.
What is included in geotechnical design portion is the soil classification and properties of soils are analyzed and characterized. The cut and fill requirements for the site to incorporate a more structurally competent base for the project. The general bearing capacity of the soil after fill as to design the footings. There are two types of footings that were designed for this project: isolated footings for column support and strip footings for masonry support. The settlement calculations were done to ensure the soil's strength. On to results. After obtaining borehole results, the top layer of soil of the site was determined to not be as competent as desired. The top layer of soil is to be removed and filled with sandy clay soil. The more competent soil will be filled at a 8-inch lift, each of which will be compacted to 95% via vibratory rollers. The fill volume is much more, as shown, as to even out and generally raise the base elevation of the site as to avoid flooding. After the fill soil was used in bearing capacity calculations, it was found to have a much higher bearing capacity. Calculations and the results shown here of the bearing capacity that included a factor of safety of 3 due to potential dead loads and live loads during the manufacturing process that will take place within the building. Another addition to the foundation design is the usage of helical piles. This is an option and is not incorporated into the initial design. The settlement of the site, especially under the foundations, was calculated to be less than 1 inch. This is up to current code and is considered to be safe and sound. As for some imagery, the top left picture shows a isolated footing that is ready to receive the steel column, and it will be incorporated via bolting it to a plate. The picture below that is a side view of that construction. The middle picture shows the strip footing design and basic form. And the right picture shows an example of what a helical pile would look like if incorporated into the isolated footings. On to transportation.
Now, to begin with transportation, with what's included, initially we started by laying out the site with roads, parking lots, and sidewalks. Now, the important factors here was the traffic flow. We wanted to ensure that even when trucks were loading and unloading, there was still room for other vehicles to pass by them. And we wanted to take economic feasible into account and make sure that we didn't just pave the entire site. It was strategically done to improve traffic flow and reduce costs. There were also considerations for the ADA and pedestrian requirements, and this included parking lot out back, as well as additional parking stalls up front for handicap. There's sidewalks and crosswalks routing from the parking lot to the entrance of the building. The next portion of transportation was to assist in the stormwater drainage design, and this included layouts of gutters on the site for the stormwater. There were also valley gutters to cross the roadway and curb drains to remove the water from the site and into the stormwater retention facility. The next major aspect of transportation design was the actual asphalt calculations. And these were done using a variety of manuals. It started with the review of truck characteristics as factors of roadway design, 2003. And this is where we verified our road widths and radiuses to make sure that even the largest of trucks would be able to drive through without any issues, without running over curbs or clipping the building. The next was the ITD pavement design, which was where the calculations were derived from for the asphalt. And this was done in relatively high detail, factoring in the actual traffic loads on the various areas of the site, whether the trucks were unloaded or loaded. And then these results were then compared to the City of Nampa 2015 standard construction specifications. And it was determined that using a standard asphalt detail was preferable so that it was a single asphalt design over the entire site. This was for constructability reasons. That City of Nampa 2015 standard construction specifications is also where we got the details for the sidewalks, curbs, and gutters. Moving on to the results. You can see on the left side of your screen is a cut section of the asphalt design. It includes a 4-inch asphalt paving with 6 inches of base, which is a 3/4 inch crushed aggregate. And underneath that is 16 inches of subbase, which is made up of a 2-inch type 2 crushed aggregate. Then on the right side of your screen, you can see the rough layout. This includes the roadways, the parking lot, as well as where the sidewalk and the crosswalk will go. And you can see the curbs and gutters in the valley gutters where it crosses the roadway, as well as the curb drains. Continuing on to the next slide. Results continued. You can see on the top left of the screen is a cut section of the valley gutters. Bottom left includes the sidewalks and 6-inch standard curb and gutter. The sidewalks are made up of a 4-inch thick concrete with 2 inches of 3/4 inch minus crushed base. On the right side of your screen, you can see details of the pedestrian ramps on and off the sidewalk, as well as the curb drains.
Hello, everyone. My name is Peter Babalta. I am the hydrology lead for this project. I am going to talk about what was included for the hydrology design portion. To start off, a retention basin was designed in order to hold all water on site. This will come provided with pond dimensions and the flow rate calculations. A drainage report will be provided in this design. It will include the calculations and methods used to determine the overall volume of water for the site. The design manual I used for this project was the City of Nampa Engineering Development Process and Policy Manual. I also used the Nampa Stormwater Design Standards for 2017. The criteria for the retention pond under the Nampa Stormwater Design required the design to follow a 100-year storm event. Calculations were expected to determine the peak discharge rate of flow using the rational method. There were design restrictions such as a maximum slope of 3:1, minimum gutter grade of 0.4%, and a maximum depth of 3 feet for a retention pond. And now I'm going to talk about results. The drainage report includes a spreadsheet that details the amount of different surfaces that will be on the 1 acre property. This was used to determine the coefficients for the rational method. After applying the formula, a pre- and post-development flow for the site was calculated. The rational method was used to determine the peak discharge rate for the site's watershed. Peak discharge is required to measure the highest runoff resulting from a 100-year storm event. The calculations performed resulted in a volume capacity of about 7,300 cubic feet. This helped me determine an area I can refer to while iterating the dimensions that suit the development site. The Nampa Stormwater Design Standards limits design to a maximum of 3-to-1 slope. Therefore, I use a 3-foot depth to a larger pond size. This led to final dimensions being 80 feet in length and 65 feet in width. This brought the capacity of the pond to a volume of 7,800 cubic feet. I could possibly get away with using a smaller dimension, but for additional safety of the surrounding environments, I saw that a larger pond was necessary. This size is expected to withhold all water on site and withstand the 100-year storm expectancy. For aesthetic reasons, the retention basin was designed as a triangle to effectively use the plot of land it will be constructed in. Finally, an open flow channel connecting between the retention pond and the nearby road closest to the building was deemed to be necessary for water control. The channel was sized to be 1 foot in depth, 4 feet wide, and 14 feet in length. As required by the Nampa stormwater design, the hydraulic capacity was required to be calculated using Manning's equation. This value resulted in 106 cubic feet per second flow for the channel. This feature is expected to improve the retaining of water on the site. And now I will give the spotlight to our structural lead.
Talk to you about what will be included in our structural portion. For the structural, there are 2 main sections. The first section is the layout of the building, which is showing the location of the beams, the girders, and the column, also showing the elevation of the roof and the elevated floor. The second section of the design is the design of the building structural element, such as the roof and the elevated floor, composite side decking, and the supporting element, which are the beam, the girder, and the column. In this section, the consideration, formulas, and detailed calculation will be reported. Please see the design document for more information. So now moving on to our criteria for the structural design. The first criteria is the load. There are some things need to be considered to get us the demand load for our design. The building is the industrial building. All the floor have to be designed to be a heavy storage load, 1-way slab for all the elevated floors, and then the load combination such as the wind load, the rain load. We use the LRFD for our design. The next criteria is the material choice. For this design, we use steel for our main material, and this project we use supply from our provider, Vocrap. Next is the code and the reference that we use for this design. As you can see, here are the code that was used in reference. We use the ASCE 710, the ISC steel construction manual, and the structural analysis. We also consider this project to be in the construction state, such as for the ease of construction, the selection of the size of the beam and the girder will be modified to meet, but also meet with our demand load. And the biggest criteria for this portion is still have to design everything to meet our both demand loads and code. And here's a showing the layout of the building. You can see where's the column, the beam, the girder placed out. and showing on the picture on the right side, showing you the elevation of each floor. And here's the result of our structural portion. On the left side, show you all the sizing, the sizes of our beams, girder, and column for the main floor, the upper floor, and the decking for the roof and the intermediate floor. The picture on the right side is an example picture showing how our decking gonna be look like for the floor. Please see the design document for more detail on our calculation of this.
Now moving on to some green and sustainable options that we came up with for each of the disciplines. To begin, on the geotechnical side of things, one idea was to reuse the cut material from the construction of the building and use that as topsoil and or to create berms for landscaping and other aesthetic features throughout the site. On the structural side of things, a couple ideas was to be able to use a green roof or use solar panels on the roof due to the design of the flat roof for this project. The picture shows a rendering of how this might look. On the transportation side of things, it was decided that we could use recycled asphalt and concrete in different portions of the site. And for hydrology, one idea was to apply some more aquatic plants and other features next to the pond to act as natural water filters and to also add to the aesthetics of the stormwater retention pond. Now moving on to the visualization side of things, here shows some of the given parameters for this project. The picture on the left shows the pre-existing site layout as well as the topography for the area. And on the right side is the building footprint, showing the dimensions of the building and the outside slab. With those given parameters and other design documents, we initially came up with a conceptual layout as shown here. This was done to just kind of lay out the different aspects of the project and make sure that everything would fit and where it would fit in relation to the other aspects. Now moving on from the 2D layout that we did in AutoCAD for the conceptual design, for the final design we decided to do a 3D model as shown here in ArchiCAD. I'll go ahead and fly through the model here just to show off and summarize some of the design elements. Here you can see the stormwater retention facility designed for the hydrology section. You can see the 3-to-1 slope on the sides as well as the 3 feet depth as shown there, as well as the inlet for the storms and how the gutters from the roadways and parking areas connect to them. Next, we can take a look at some of the design elements of just the structure itself as well as the surrounding concrete pads. Here you can see that brick veneer layer that also has the CMU wall within it, which we'll show here in a minute without. This area is where the trucks would be loaded from one side, as well as the trucks could be loaded from this other side as well. Here we can take a look from the inside. We can also go to this front section to show off where the second story mezzanine is. Moving on to show off the building's beam, girder, and column layout, as well as the foundation properties. Here's a view of the structural portion showing just the girders, beams, and columns, as well as the foundation. Here you can see the location of the mezzanine, the 2 different roofs, as well as the balcony to the second floor. You can also see down below here the different footings, that were sized based off of the bearing capacity from the geotechnical side. For the geotechnical portion of this model, you can see what we start with in terms of the site layout before any construction happens. See the topographic lines overlaid on top? Here's a view showing the site layout with the cut requirements that will later need to be filled with SC soil per the geotechnical design. Here's just a section view showing the different areas of fill that will be required on site. This first section was determined to need 6 feet worth of fill with that SC soil, whereas this back portion was determined to need 8 feet of fill. Now moving on to the transportation side of the project, here you can see a good cross-section of the typical roadway. Here you can get a good overview of the other aspects designed in the transportation portion of this project. You can see the different ramps and locations of certain road markings, the curb and gutters, the ramps, as well as the pedestrian walkway. Here we also have a typical truck just to show size, as well as some bollards for certain spots along the building that might cause a potential for a truck to hit it. Here we can also see where the valley gutters intersect with the regular curb gutters along the roadways, as well as the valley gutter that connects with the pond inlet that goes to the stormwater retention facility. Up front here, we can also see where there's some ADA compliant parking spaces, as well as a ramp for easy access. And with that, that concludes the overview of our 3D model. Moving on from the visualization portion, here's also some of our citations. And we also wanted to give out a couple shout outs to a few of the mentors that helped us with our designs along the way. So from everyone here at the 5-Star Design Group, we'd like to thank you for watching our presentation and hope you have a great day. Thank you.